Hi, everyone. We'll just wait for a few more minutes and we'll get started at 5 o'clock. Hi, everyone, and welcome to our Hotg AI API workshop. Today, we're going to be going through a few walkthroughs through our tools, Rune, and how you can integrate runes into your own applications and use machine learning for your hackathon this weekend. So before we begin, we actually have an application which you can download and use. And we'll be taking a look at this application a little later on in the workshop. So here's a few QR codes for if you want to download it for the App Store, the Play Store, and the Progressive Web application. I'll just leave this on for a couple of seconds so you guys can get your download the app, and we'll get started in a bit. So let me walk through the current state of ML. Well, currently machine learning is pretty centralized with extremely large models. As you can see in this image, Microsoft Turing's natural language generation is currently the largest model in the world with over 17 billion parameters. Now, what this means is if you want to use the model, it has to be, the model itself is hosted on a cloud service, and you have to access it by sending data through the cloud. And this actually makes it pretty difficult if you want to, this has two basic disadvantages. The first is that, well, there's no privacy. You're sending data to whatever companies, Microsoft, NVIDIA, Facebook, and they're having access to all of the data sets that you're sending into them. And the second thing is it requires a large amount of data to be sent to be processed. So ML on the edge is over the horizon. Machine learning is basically predicting outcomes using existing data. Currently, there's over 50 billion edge devices across the world, and this is set to exponentially increase over the next decade. Endpoints, all of these different edge devices are connected to different types of sensors. So motion sensors, image sensors, touch sensors. And through these different types of sensors, we can actually use them to collect data and directly run machine learning on edge devices. So Rune, the solution for a fragmented industry. Currently, edge devices have operating requirements which are enforced by the manufacturer. So there's kind of hardware locks. And on top of that, each device has a different software requirement to run machine learning models. So if you want to run a model on Android device, well, you're going to need to program in Kotlin. And if you want to run something on an iOS device, so an iPhone or an iPad, you're going to have to program it in Swift. And if you want to deploy a web application, well, then you have to use JavaScript. So Rune consolidates this entire process into a single pipeline, which can be deployed on any device. So what does this look like? Let's have a look. So how would we perform artistic style transfer? So here's a use case, where we can use ML. So what we'd end up using is the neural style transfer model. As you can see from these two images, there's a content image and there's a style image. And the style image is basically what's kind of overlaid on top of the content image. Now, what actually happens is both the style image and the content image are fed into two different types of models. And so each of these pixels are scanned, converted into data points, and sent into the two different models. Then this model spits out some sort of data, which is sent through a third machine learning model, this neural style transfer model, which results in the output of an image similar to this. So it is the dog, which was the content image, but it kind of has the artistic flair of the style image. And here's a little bit more about an image about how the model works. So as I mentioned earlier, each section in both of the images are scanned, sent through their own neural networks. And there's the final output being spun out. It looks something like this. So this, for example, is a house with the image of a starry night. Well, let's actually test this out on our phones. So earlier, I shared the QR codes to download it on your mobile phone. And I actually have this downloaded on my phone. So with the Runic mobile application, we have a whole bunch of runes here. And what we're looking for is the image style transfer rune. So let's start by uploading the style image. So let's take this photo. And for the second image, well, I've got a model Ferrari F1 car here, and we can scan that. And there's this kind of artistic overlay. Now, the lighting condition in my room isn't the greatest, so there's a little bit of, it looks more white out than it would normally be. But yeah, that's the style transfer rune. And the greatest part about this entire process is, say if I turn the Wi-Fi off, I'd still be able to actually scan the rune, run the rune and scan the photos. And what this means is none of your data is actually being sent. So the Wi-Fi is actually still off, even though it displays the Wi-Fi connected there. For whatever reason, my phone seems to disagree with me. But yeah, so the focus of the rune, as I mentioned, it tackles two problems. One, we're directly able to run machine learning models on edge devices. So in this instance, we're able to run it on my mobile phone. And the second thing is, even though the Wi-Fi is actually turned off and it's not connected, we're still able to run the Rune. So what this means is none of your data is actually being sent or collected. Everything's being run locally, and no companies taking advantage of any data that you're trying to send in. So how would we actually build this ourselves? Let's get started. First thing we need to do is actually download the models itself. And to do that, we'd have to visit, we can actually take these off TensorFlow's website. This is TensorFlow Hub, and they have a whole lot of different machine learning models. And here's the style transfer. So what we want to do is, say, view the source on GitHub. And if we were to scroll down once this loads, there's actually the two style transfer models are here. So what we'd want to do is download them. The style transfer model and the prediction model. And while this is downloading, let me actually pull up the Finder. There you go. So let me actually open this in Visual Studio Code. So as you can see, we earlier downloaded the style transfer model and the prediction model. So here we have the transform and the predict TensorFlow Lite models. Now that we have the models ready, the second thing that we're going to need is the Rune tooling. So let me do like a quick walkthrough of an installation process for this. So the first thing we'd want to do is open up Terminal. And well, there's two basic things that we need to install. The first thing is we need to install the Rust compiler. Proceed with the installation. And the second step is to install the cargo command line tool, which can actually directly be installed while this is happening in the background. We can go to the Rune repository. And this is a public repository on GitHub. And all of these links will be shared after the workshop's over. Or actually, let me share this right now with everyone so you can kind of follow along. And now what we want to do is we can go to the nightly releases, and we can download based on what device we're running. So if we're running like a Linux device or an Apple device. And if you are running a Windows device by any chance, if you were to follow our documentation, which I'll actually post a link for, we have further steps, further detailed installation steps. So let's download the Apple tool, show in Finder. And now what we want to do is we want to unzip this, open this file. So we unzipped it, opened the file, and we want to copy this Rune file over to our .cargo repository. And inside bin, we kind of want to copy this over. And go back to terminal. The next step would be to actually get this Rune tool working. And how we do that is we'd run chmod plus x. See. So first we'd follow the path stored in library. Or my mistake. Dot cargo. And bin. And here we can do chmod x Rune. And what we did there is we changed the permissions of the file. So now it's an executable file and can be run. So now if we were to run Rune version, for example, Rune cannot be opened because the developer cannot be certified. So I guess we have to go to system preferences, security and privacy, authenticate. Rune was blocked, so we have to allow permission. And there, we should be good to go. So now our Rune version should work. And open. There you go. So we currently are using 0.7.1 dev version of the tool. Okay, good. So now that we have the tool installed and the model is ready to go, what we can start doing is building a Rune file. And what the Rune file is here's earlier I mentioned in my presentation that Rune consolidates a process into a single pipeline. So the runefile.yaml is where we actually end up building this pipeline. So here's an example of how the runefile.yaml kind of looks like. So let me open a new Visual Studio Code instance. New file. And what we want to do is save it somewhere first. So let's make a new folder. We'll call it style transfer, or let's just call it test for now. Create, open. So now what we can do is create a new file and call it runefile.yaml. Now we can actually get started on programming our data pipeline. So the first thing we need to, which any Rune file should have, should be an image. And the image is actually the base operating system for a Rune, and some sort of version number. So, and the version number is used to keep track. Say if you're to create multiple Runes, then you can change up this version number, and you can use the Rune command line tool to know which Rune's the latest one that you actually want to be using. So now we need to actually get started on building the pipeline. And I said earlier in the workshop that we're actually taking in a few different inputs. So the first input is for the content image. Now we have something called a capability. And here's where we outline the type of input that's coming in. So let's say if we were taking some sort of audio stream, then we'd want to type this out as sound. But since we're using pictures, well, we're taking the image capability. And outputs. So how would we actually know what the type of the output is? And this is actually told in the machine learning model itself. So if I was to pull back terminal, cd, test repository, what I'd wanted, so since we're looking, so based on what the image is, so how would we know what type it is? Well, all image types are actually of type U8. And the dimensions are actually mentioned in the documentation in the documentation over here. And well, I'll just tell it to you. We know that the dimensions for the model are actually 384 by 384 by 3. And finally, a few different arguments that it's being sent in is, again, the width, the height, and the pixel format RGB. And the reason for these arguments is that this can be exposed to the front end of your application. So say if you were to deploy this on a mobile application, through the arguments, you'd know that, okay, the pixel format is RGB. Otherwise, you wouldn't be able to directly read the Rune and know that the pixel format that it's whether it's taking in like RGB pixel format or if it's grayscale or what the size of the images need to be transformed to. So that's what this arguments do. Okay, so now that we've gotten started on the first step, the content image, the next step of this is to actually take in another image, which is the style image. And for this, again, most of this is the same. Again, we're taking an image, so we need an image capability. The type's U8, but what's actually different is the dimensions are 256 by 256 by 3. And again, we need to mention this. We need to add arguments. There you go. And now what we have is something, and so let's actually, so now that we have the images being taken in, we need to send these images to the models. But if we were to have a look at the models themselves, here, Rune, we can use the Rune command line tool for this. And we actually have a pretty nifty tool called model info, which gives us the information from the TensorFlow Lite models. So if we were to take the style transform, so let's look at the style predict. I'll predict.tflight. And this tells us that the input being taken in is actually floating point 32. But our inputs for the images being sent in are U8. So we need to have some sort of data transformation occur to convert the U8s into floating point 32 bits. And for this, we actually do have what we call processing blocks. And here's where we can do post-processing and pre-processing of data. So for example, here we have something called normalized content image. So what we're doing is we're taking this content image, feeding it in as an input, and we're running a processing block. And what this here is it's outlining to our Rune repository, which I showed you earlier. And it's basically showing the path to a repository. So proc blocks image normalization, and here's where the processing block's coming from. And all of this Rust code, which converts the U8s to F32, is basically being run in this processing block here through this block of code. So again, we need to repeat this since we're taking a few different types of images in. So the output type for both of these is F32, and both of these use the image normalization processing block. And now the next step is to actually outline the machine learning model itself. So I mentioned earlier that we have two machine learning models. So the first one, we'll call it style vector. And here we're currently showing the path to the processing block. So here, if we were to say ls, so the Rune file, in the same directory where the Rune file is, we actually have the style predict TensorFlow Lite machine learning model. And what this is doing is it's showing the path to that. And the input we're taking in is the normalized data. And the output here, well, you might say, how do we know the output? Well, earlier we ran the model info command, and it provided us the model output. So again, this needs to be repeated and now we're performing the actual style transform. So the data output from style vector is fed into style transform and the normalized content image. So what this model is doing is it's combining the two models together. And finally, we have our output. So we're outputting it to serial, but there's different options. And what we're taking in here is the style transform. So so the way this entire pipeline works is you have two images which are being taken in. Then both of the images are being the data is being processed to convert from type U8 to type floating point 32. And then it's fed through both the machine learning models. And finally, the output of the machine learning model is sent. So now we can actually test this out. So we have the Rune file ready. Now what we need to do is we actually need to build the Rune file. And what we're doing is we're using the Rune command line tool to compile this entire Rune file into a single Rune binary, which is what can be deployed onto your various devices. So the final step, it said the Rune was written to test.rune. So you can see here, there's a test.rune. And this is the same Rune which was taken and later deployed onto our mobile phone as the style transfer Rune. So in addition to the style transfer Rune, let me refresh this. The images haven't seemed to have loaded. So in addition to the style transfer Rune, my phone doesn't seem to want to work with me right now. We actually have many other different types of runes. So we have some mobile net models which can identify different objects. So if you want to integrate that into your applications. So the entire list of runes that we have is actually all up on our repositories. And all of the links will be shared right now, actually. So you can actually join our community. Here's the QR codes for our Twitter, LinkedIn, and Discord. And we're actually most active on Discord. And just come by, swing by, join us, have a chat. And we can actually provide you some help for your projects this weekend if you find yourself getting a little bit stuck. And if you have any questions, just feel free to hop onto our Discord channel, and we're all available to help you out. So join Discord for additional support. Thank you very much for following this workshop, and I hope you guys have a great weekend of hacking. So it doesn't seem like we have any questions, but if you do have any questions, just shoot it in the chat, and I can help you out. Thank you, Julia. So thank you, Sheikh. Thank you, Guneet. And as I said earlier, if you have any questions, feel free to hop onto our Discord, and we can provide you further support, and we can answer any questions that you guys have. And I myself will be available throughout the entire weekend as a mentor. So if you have any questions, you can actually either join us on our Discord, or you can just reach me out for mentorship during the weekend. Thanks, Nathan. And I feel like I should mention, in this example for the Rune file, what we did is we went through with an image style transfer Rune. But we actually have support for different type of capabilities. So if which we're working on. Actually, let me share that. I mentioned earlier that I'd share some documentation links with you guys. There you go, hachi.dev. So feel free to check out our documentation. And yeah, have a great weekend of hacking, guys. Thank you, Sheikh. I hope I'm pronouncing that correctly. Thanks, Nathan. You too. And I'll probably stick around a little bit longer. If you guys have any questions in the chat, just feel free to. Oh, okay, cool. Yeah. I'm glad I'm pronouncing your name correctly. No, I won't be doing any more workshops this weekend. But as I mentioned, I will be providing mentorship support. And I don't think I said this earlier, but we actually, yeah, so yeah, no, there won't be any other workshops this weekend, but we actually did have a workshop earlier, which one of my colleagues, Michael, gave earlier in the week. And I think the link to that may already be on Hack the Nord's channel. So you guys should feel free to check that, check his talk out as well. It wasn't exactly a workshop like mine was. His was a little bit more technical, went into a few more details about Rust and the likes. Yep, and as Karthik mentioned, we will be running a few more live coding sessions on our Discord over the next few weeks. So if you join us, well, there's an additional perk. Yep, and as Karthik mentioned, we do have an easier interface to build runes coming out. And a lot of our tooling is open source, so we definitely appreciate any feedback that you guys have, or if you guys want to contribute to our code base itself, that would also be greatly appreciated. Also, it'll be a pretty neat exposure to both machine learning and Rust, which is an up and coming language, which is increasing in demand. Uh, Okay, so it seems that we don't have any other questions. So if you're still here, well, thank you again, and have a great weekend hacking, guys.